Good morning, everyone. Happy Friday. Welcome to TBE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. Ms. Patricia and Ms. Stella will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. Welcome to Friday Happy Math Hour. Today we're going to go over some topics for Exam 1 review. And then if you have any questions, let us know. So we'll start off with the first example, finding the distance and the midpoint between the points 8, 4 and 8, negative 6. So whenever we want to find the distance and the midpoint, one of the things that we could do first is label our points as x1, y1, x2, y2. And then from there, what we can do is recall the distance formula, which is given by x2 minus x1 squared plus y2 minus y1 squared. And then we can just plug in our numbers. So here x2 is 8, so we're going to plug in 8 minus x1, which is 8 squared. And then we have negative 6 minus 4 squared. So if we simplify, 8 minus 8 is 0. Negative 6 minus 4 is negative 10. If we square both of those numbers, 0 squared is 0. Negative 10 squared is 100. So once we get this as our answer, then your instructor might ask you to simplify. So to simplify, the square root of 100 just comes out as 10. Okay, so in the same way, we can find the midpoint, but this time the formula is x1 plus x2 divided by 2 and y2 plus y1 divided by 2. So we can plug in our numbers, and so we get 8 plus 8 divided by 2 and negative 6 plus 4 divided by 2. So our midpoint would be 16 divided by 2 and negative 2 divided by 2. And if we simplify further, we get 8 divided by negative 1. Notice here that we have parentheses. And the reason we have parentheses is because this is a point in the graph. Okay, so let's look at some more examples. Okay, so let's go to the next slide. So one of the examples that you might be asked is to write the standard form of the equation of a circle. And so here they give us the center, and then they give us the radius. And so what we want to recall for any problem that you're working is if you have a formula, then what you want to do is go ahead and write out the formula so that you have it right next to you. So here our formula is x minus h squared plus y minus k squared equals r squared. So the h and the k represent our center. Since they give me the center, I can label the first x coordinate as h, and I can label the second coordinate as k. And then they give us our radius, which is 2. So I'm going to label it r equals 2. So if we substitute these values, then we have x minus h, again, h is negative 4, and y minus k, k is 2. And then our radius, which is r, is 2. So we want to simplify. And so negative negative is positive, and then 2 squared is 4. So this would be our equation for this circle. So anytime you're working with a circle, remember that your x and y are going to be squared. Okay, so let's look at a different one. Now they give you the equation, and we want to find the center and the radius. So again, here's the standard form of a circle. And I'm going to write down the equation they give us right below it so that we can compare. So here we have a subtraction. We have subtraction. So that means that h is going to be 1. But in this second one, we have subtraction. But the one that we have in our equation is a positive or a plus sign. So we'll deal with this here in a second. And then we have r squared is 25. So let's rewrite this a little bit different so that we can take care of this plus symbol. So the plus, we're going to change it to subtraction. And we can do that if we change the value of the number 2. And we can do that since negative negative will become positive. And so now if we compare with the equation, we can see now that we have our subtraction. So that means that k is going to be negative 2. And then r squared is equal to 25. So our center is going to be 1. And then it's going to be negative 2. And then for our radius, we can write it as r squared is equal to 25. We can take the square root of the square root on both sides. So we end up with r is equal to the square root of 25. And the square root of 25 is 5. So remember, when we take the square root, we get a plus or minus value. But since we're dealing with distance here, the radius from the center to the end of the circle, we only consider the positive value. Okay, so I think I have one more example on the circle, but it's to graph it. So in order to graph a circle, you need to identify the center, which is 1, and then negative 2, which is what we did earlier, and then our radius is 5. So to graph, I like to plot the center first at 1, negative 2, and then the radius is going to go from the center all around the circle. So what we do here is from the center, we can go 5 to the right, 5 up, 5 to the left, and then 5 down. And so that's going to look something like this, where we have our points on the outside, and then we can sketch the circle around it. Okay. Okay, so the next thing we want to look at is the intercepts. So it says find any intercepts, and then we're going to test for symmetry. So to find the x-intercept, remember that y is equal to 0, and then we get to solve for x. And so again, the intercept is where the graph crosses the x-axis, and that's why y is equal to 0. So we substitute 0 for y, then we're going to solve for x. So I'm going to subtract 1 on both sides. So subtract 1 on both sides, we get negative 1 equals negative 4x, and divide by negative 4. So we get x is equal to 1/4. So this is my x-intercept. And then the y-intercept, we're going to let x equal 0 and solve for y. Remember that your y-intercept is where the graph crosses the y-axis, therefore making our x 0. And so we substitute 0 for x. We get negative 4 times 0 plus 1. And so my y-intercept is going to be 0 and 1. Okay, so those are our two intercepts. Then it wants us to test for symmetry. So one way you can do that is if you know what the graph looks like, or if you plot the graph. So if I plot 1/4 and 0 and 0, 1, then I can observe my graph here. There's no symmetry on the x-axis or y-axis or origin. But if if you don't want to graph the equation, then we do have a way to do it algebraic. And so to find if it's symmetric to the x-axis, we're going to replace y with a negative. Okay, so let's go ahead and do that first. So here's my equation. So I'm going to first replace y with a negative, and then I'm going to solve for x. So to solve for y. So to solve for y, I can divide by negative on both sides. And we end up with y equals negative 4x divided by negative 1 plus 1 divided by negative 1. Simplify. So we end up with y equals 4x minus 1. So to check for symmetry, you want to compare your final answer here to the original equation, which is up here. And you want to ask yourself, are they the same? Since they're not the same, then this means that the graph is not symmetric on the x-axis. Okay, so let's try the y-axis. For the y-axis symmetry, we're going to replace the x. We're going to replace it with a negative x. So let's do that first. So we have y equals negative 4. Replace the x with a negative x, and then simplify or solve for y. So negative times negative x is 4x plus 1. So again, we can compare and we can see that my result here is not the same as my original equation. Therefore, there's no y-axis symmetry. And then last, the origin, we get to replace both the x and the y. So let's go ahead and do that. So there's my equation. I'm going to replace y with a negative. I'm going to replace x with a negative. So we have negative y is equal to negative 4x times negative x. So if we simplify, negative 4x or negative 4 times negative x is positive 4x. And then we're going to divide by negative 1 so that we can solve for y. So we end up with negative 4x minus 1. Again, we can compare our equation. This is my equation here, my final one. Compare it with the original one, and we can see that they are not the same. Therefore, this graph has no origin symmetry. And we saw that from the graph, right? It had no symmetry. Okay, so you can do this by graphing the equation, observing it, or by using the algebraic test. Okay, so determine whether the equation represents y as a function of x. So there's different ways to do these problems. The quickest way is to be able to recognize what type of equation you're working with and then use the vertical line test. So if we look at the first one, can anybody tell me what type of graph this is if we graph it? Is it going to be a circle, a parabola, a square root, a line? What is this going to be if we graph it? A line. So Salvador said it's a line. So yes, if we graph it, it's going to be a line. And so this would pass the vertical line test. Remember, if you draw a vertical line and it only crosses your graph at one point, then it makes it a function. So since it passes the vertical line test, then yes, this is a function. What about the second one? What type of graph is that? Line, circle, parabola, square root, absolute value. Those are all of our parent functions, right? So this belongs to which family? What type of graph will it have? A parabola. So if you graph it, it should look like this. And so again, the parabola, if you draw a vertical line test anywhere on the graph, it's only going to touch the graph at one point, making it a function. So yes, this is a function. And then we have y equals square root of x minus 4. This one here belongs to the square root family. And so the basic shape for that and the graph for this is kind of an arrow shooting to the right. And so if you draw a vertical line test, it's also going to pass it. And then last here, we have x squared plus y squared. And so earlier I said that if they're both squared, then our graph is going to be a circle. And so any circle here, if you draw a vertical line test, it's going to cross in two parts of your graph, making it not a function. Okay. So let's do one more. Y equals x cubed minus 1. So the parent function is a cubic. So it's going to have that same shape, but shifted downward 1 unit. So our graph ends up here. So if we draw a vertical line test, it's still going to touch the graph only in one location. So that's going to make it a function. Now for this one, I'm going to go ahead and show you algebraically how we can figure out if it's a function first, and then I'll show you the graph. So here, if we solve for y, notice that all the previous problems, they were all solved for y. Okay, so if you're, well, except for this one, but if you're trying to figure out if it's a function without the graph, then that is my recommendation, is solve the equation for y. So if we do that with y squared equals x plus 4, then I'm going to take the square root here. And since I took the square root, then we have to consider the plus and minus. So we get y equals square root of x plus 4 and y equals negative square root of x plus 4. And so if I was to choose any point, let's say 0, and plug it in for both of these, when x is 0, here I get a 2, and when x is 0, I get a negative 2. So x equals 0 is going to two answers, 2 and negative 2. And so since it goes to two answers, then it makes it not a function. This is the graph for this equation. And so you can notice here, if you draw a vertical line, it's going to touch your graph in two places. Okay. So one of the things I tell students is, if you personally have to take the square root as we did here, then it's not going to be a function. But if you already have, let me go back to the other slide. If it's already showing you the square root of x minus 4, then they're only considering the positive one. So in this situation, it's still going to be a function. But in the other situation, since you took the square root, you have to consider the plus and the minus for that. Okay. All right. So let's keep going. So graphing. You've learned different ways, right? You learned the point plotting, you learned the x and y intercept, you learned that you can use the slope intercept form of a line. And then we looked at transformations. And so for these examples, that's kind of what we're going to be using. So it says use the graph of f of x equals square root of x to write an equation for the function represented by each graph. So whenever I'm working with these, I always like to graph the parent function first. And so here's my parent function, just so that I can reference it. Okay. So then I like to ask myself, what would I have to do to get this graph to end up in this location? Okay. And so just by looking at it, I know that I'm going to have to go down, and I know I'm going to have to go to the left. Okay. And so this is where your transformations come into play. So I'm going to do it step at a time. So in order to make something move to the left, I'm going to have to add a number. And so I can see here in my graph that it was shifted 2 units to the left. And so I'm going to write it as square root of x plus 2. So now we can see that the graph was shifted over to the left. And now I need to move it down. Okay. So in your transformations, to move something down, we're going to subtract. So we're in this case, we were at 0, and now we're ending up at -8. So we're going to subtract -8 units. And so now our graph here is the same as this one up here. Okay. So now let's make it a little bit more interesting, right? So the graph now looks like it's pointing in the wrong direction. And so that's going to involve some reflections, right? So we start off again the same way. Take the parent function. This is my parent function. I know that the graph, can you guys see the screen? Okay. So here, oh, you can't. Okay. So, okay. So some people can. Okay. That's interesting. Okay. Do you want to reshare? Okay, let's reshare just to make sure. So let me stop it really quick, and then we can reshare. Okay, let's try to reshare and see if it's better. And let me go to the slide. Okay, I'm just scrolling down to get to the slide. Let me see. Okay, we're almost there. Can you share those that you couldn't see? Okay. So hopefully it wasn't for like 30 slides that you couldn't see, right? So yes, please let us know as soon as possible if you can hear or you can't see a screen. But thumbs up if you can see the screen already. Mr. Morial, you have a question? Go ahead, sir, and you can answer. You can ask your question if you have it.
No, I'm good. I just was
Okay,
looking for this
sounds
thing.
good.
I can see it though.
All right, sounds good. So let's continue here. So what I was mentioning earlier is that now this graph is pointing like in the opposite direction, right? So it's going to involve some reflections, but it's always a good idea to write your parent function so that you can compare. So we can see that this graph, in order to look like this one, it has to be shifted down and it has to move to the right. So that's one thing for sure, right? So let's go ahead and start with this. So I also needed to reflect. So if I add a negative on the outside of the square root, it reflects it in this direction. Okay. And so it doesn't quite take care of my direction that it's pointing. So let's continue. So if I add the negative on the inside, then that causes a reflection on the y-axis, as you can see by this line that I'm pointing to. It's going to reflect to the left. So when you add it to the outside of the function, it reflects on the x-axis and it looks like this. But when you add it on the inside of the square root, then it reflects on the y-axis. Okay, so now we're looking at this purple part of the graph that I'm tracing with my arrow. Okay, so it still doesn't look like this one, but at least we have it pointing in the right direction, right? All right, so let's continue. Now we can apply some of the shifts. So we needed to move to the right. So if we wanted to move to the right, then we're going to have to subtract -2. So I've shifted my graph to the right. And so now we're located here in this graph that I'm tracing. It's in blue here, but I'm tracing it as well. And it's still not in the right location. So now we needed to move down 5 units. So if I move down, am I going to add 5 or am I going to subtract 5? Any takers for that one? Am I going to add 5 or subtract 5? Okay, so we're going to subtract 5. So when we subtract 5, it causes the graph to shift all the way down. And so now this graph is the same as this graph. Okay, they look a little bit different, but it's because of the counting. Here I'm counting by 2s, here I'm counting by 5s. Okay, so again, my suggestion is start with your parent function and then work your way down from there. All right, so let's switch some gears here. One of the main topics in chapter 1 is to write equations of a line. And so if we want to do that, you need to have two things. You need to know the slope and you need to have at least one point. So in this example, they give me the point, but they don't tell me what the slope is. But they also give me some important information. They give me an equation, and then they tell me that the line is parallel, and they want us to find one that is perpendicular. So we're gonna find a parallel one and a perpendicular one. Okay, so let's go from there. So first, we're gonna take this line, and we're gonna solve for y. So I'm gonna go ahead and subtract 8x on both sides. I'm gonna divide by -2. So -8 divided by -2 is +4, and 3 divided by -2 is -3/2. So for this line, all we care about is the slope. And so my slope is 4. So I'm gonna highlight it over here, m equals 4. So now you have the two things you need. You have your point and you have your slope. So from there, we can use the point slope form of a line, or you can use the y-intercept form of the line. So it just depends which one you feel more comfortable with. I'm going to use the point slope here. So for parallel, the important word here, whenever two lines are parallel, then that means that you're going to use the slope. So we know the slope of this line was 4. So for the new line that we're looking for, we're going to use the same slope. And then my 0.81, I'm going to call it x1, y1. And then I'm going to use the point slope formula here. So I'm going to substitute the values that I have. And so I have y minus y1. y1 is 1. And then my slope is 4. x1 is 8. So we're going to solve for y. So I'm going to distribute 4 into the parentheses. And so that's going to give me y minus 1 equals 4x minus 32. And then I'm going to add 1 on both sides so that I can finish simplifying. So y is equal to 4x, -32 plus 1 is -31. So if you were to graph this equation and you were to graph this equation, then they're going to be parallel to each other. They're never going to cross. Okay. Now for perpendicular, we still use the same point, but instead of using 4, we use the negative reciprocal of this number. So the reciprocal of 4 is 1, 4. So we're going to plug in the information. So we have y minus 1 equals negative 1/4 x minus 8. Distribute the negative 1/4. So we get negative 1/4 x minus 8 times negative 1/4. Keep simplifying. Negative 8 times negative 1/4 is positive 2. And then we're going to add the 1. And so our answer is going to be y equals negative 1/4 x plus 3. Any questions on that one? Okay, so that is writing the equation of a line. So anytime you want to do that, you want to make sure that you have two things, right? The point and then the slope. And if you don't have the slope, at least you need to have enough information to find it. So if we look at this one, the instructions is still write the linear function. So in order to do that, as I mentioned, we need to know the slope and we need to have 1 point. So here it doesn't look like they give me anything, but if we kind of look at this closer, I know that the 1 here is representing the x coordinate, and I know that 7 is representing your y coordinate. And that is because when you input x as 1, you get an output of y of 7. So here's 1 point, 1, 7, and then 0, 8 is another point. So I can take both of these points and I can use my slope formula, y2 minus y1 divided by x2 minus x1. Substitute these values into the equation. So y2 is 8, y1 is 7, x2 is 0, x1 is 1, 8 minus 7 is 1, 0 minus 1 is negative 1, so my slope is negative 1. So now I have negative 1, and then we need at least 1 point, which I have 2 points, but one of these points is very special. Can anybody tell me which one's a special point right here? So the special point is going to be 0, 8, but why is it special? And the reason that it's special is that that's actually your y-intercept. Okay, so this is your y-intercept. That means that 8 here is represented as b in this slope-intercept form. So your slope is negative 1 and your b is 8. So if we simplify, we get y equals negative x plus 8. So let's say you're working on this on your exam and you forget about the special point here, 0, 8. Then there's no problem. Once you find your slope, then you can go back to the point slope formula and plug in your numbers using either 1, 7 or using 0, 8. And at the end, you're going to end up with the same answer. So sometimes I tell my students, use whatever you feel more comfortable with. So some people want to just use this because that's what they feel comfortable with. And then others will always remember that when x is 0, that means that 8 is, or this number is going to be your y-intercept. Okay. All right. So, Mr. Isasi, did you want to take over, or do you want me to continue?
I can take over it if you want me to.
Okay, sounds good.
Okay, now, here we're going to find the value, the function value if possible. So here, trying to find f of 1 means that we're going to plug in 1 for every x. Okay, so we're going to plug in the f of 1 means we're going to plug in the 1 for the x's. So then we're going to simplify, right? So f of 1 will give us 3 times 1 minus 8. So it's going to give us 3 minus 8, which will give us equals to negative 5. So f of 1 equals to negative 5. Now, in the similar fashion, let's evaluate the function at x plus 4. We're going to do the very same thing as what we did earlier with the f of 1. So we're going to plug in x plus 4 for every x. Okay, so we're going to plug it in here. So it's going to be 3 times x plus 4 minus 8. Then we're going to distribute. Right, so it's going to give us 3x plus 12 because 3 times x is 3x and 3 times 4 is 12. And then we just bring down the minus 8. And the 12 and the minus 8 are like terms. So 12 minus 8 will give us 4. So this is my my solution after we evaluated at x plus 4. It'll be 3x plus 4. Yeah. Okay, now, again, find the value, the function value if possible. So here we're going to find g of 2, which means we're going to plug in 2 for every t. Okay, so we're going to plug it in here for the t squared and also here for the t. So we're going to have, now we simplify. So it's going to give us 2 squared is 4, and 6 times 2 is 12 minus 12. So it'll be 20 minus 12 plus 4. Right, so this will give us g of 2 will be equal to 12. So g of 2 is equal to 12. Okay. Now let's find g of t minus 2. So again, I'm going to plug in t minus 2 for every t. Okay. So now here, once I substitute t minus 2 for every t, so here I have to do the FOIL, right? So let's see, we're going to have t minus 2 squared will give us t minus 2 times t minus 2. So t times t will give us t squared. And then t times negative 2 will give us negative 2t. And negative 2 times us also another negative 2t. And negative 2 times negative 2 will give us a positive 4. Okay. So they will give us t squared minus 2t minus 2t plus 4. And then we'll just bring down here, we're going to distribute the negative 6 times t will give us negative 6t. Negative 6 times negative 2 will give us a positive 12. And we just bring down the 4. So the negative 6t plus 12 plus 4, we just bring it down and we combine like terms. But first of all, I need to distribute the 5. Okay. So here, let's distribute the 5. So it's going to give us 5 times t is 5t squared. 5 times negative 4t will give us negative 20. And 5 times 4 is 20. And we just bring down the negative 6t plus 12 plus 4. And now we combine like terms. Let's see here, 5t, right? So there's no other 5t squared, so we'll just bring it down. We have negative 20t minus 6t will give us a negative 26t. We have 12, we have 20, positive 12, and positive 4. 20 plus 12 will give us 32. 32 plus 4 will give us 36. So this is my, the function evaluated at t minus 2, which will give us t squared, 5t squared minus 26t plus 36. So now we're going to be doing g of t minus g of 2 for the very same function as before. On the g of t, right, we got 5t squared minus 6t plus 4. When we evaluated g of 2, we got 12. So let's put them together. So g of t minus g of 2 will give us 5t squared minus 6t plus 4. That was the g of t. And minus g of 2, the g of 2 was equal to 12. Now we can combine the 4 minus 12 will give us negative 8. So the answer will be 5t squared minus 6t minus 8. Okay, now here it says to find the following. We're going to find f of f plus g of x, f minus g of x, f times g of x, and f divided by g of x. F divided by g of x. So here, guys, where it says f plus g of x, we're going to add the f function and the g function for part A. Okay, so here we go. F of x was x plus 2, which is in red, and g of x is in blue, which is x minus 2, and all we do is combine like terms. So we have x plus x is 2x, and 2 minus 2 is 0, so f plus g of x is equal to 2x. Now for B part, we're going to subtract the g function from the f function. So f minus g of x, here's my f function in red, which is x plus 2. And then minus my g function is x minus 2. Here, let's don't forget to distribute. This is like a negative 1 here. So negative 1 times x will give us negative x. And negative 1 times negative 2 will give us a positive 2. Now we combine like terms. So x plus x minus x will give us 0x. And 2 plus 2 will give us 4. So for the f minus g of x is equal to 4. Now comes part C. We're going to be dividing the function f, multiplying the f times the g function. So again, the f function is in red, which is x plus 2, and the g function is in blue, which is x minus 2. So here, if you notice, this is the difference of two perfect, the difference of, well, it's going to be the difference of two squares. Let me see here. Yeah, x times x will give us x squared. X times negative 2 will give us negative 2x. 2 times x will give us positive 2x, and 2 times negative 2 will give us negative 4. So here, guys, I did a mistake here. This is supposed to be negative 2x plus 2x. This is supposed to be just x squared minus 4. Okay, sorry about that. Now let's do the f divided by g function. Here we go. So, so here, right, so it's going to be the f function divided by the g function. The f function, again, is in red, so it's going to be x plus 2 divided by the g function, which is x minus 2. So this cannot be simplified, so the solution would just be x plus 2 divided by x minus 2. Okay. Now, what's the domain of the f divided by g function? Okay, if you can recall, I believe from 2 weeks ago on the Friday Math Happy Hour, we went over the domain. So here, right, this is like a rational expression, right? On the right side, so the denominator cannot equal to 0. So we set the denominator equal to 0 and solve for x. Okay, let me go back here. Yeah, so it'll be x minus 2 equals 0, right? So x equals to 2. So the domain can be all the numbers, all the real numbers except 2. But they want us to write it in interval notation. Okay, so it's going to be every number from negative infinity all the way to 2, and we put parentheses because the 2 is not included. And then U stands for union, and then it goes from 2 again with parentheses because 2 is not included, and it goes all the way to positive infinity. So this is my interval notation for the domain of x minus 2, here on the denominator. Okay, now, here we're going to evaluate the function f of x plus 3 and g of x squared minus 2. So here we're doing the f times g function. So it's going to be f times g. So my f function is in red, which is the x plus 3, and my g function is in blue, which will be the x squared minus 2. So here we have to do the FOIL, right? So we're going to do x times x squared. Let me see here. It's going to be x times x squared will give us x cubed. X times negative 2 will give us a negative 2x. And 3 times x squared will give us a 3x squared. And 3 times a negative 2 will give us negative 6. So what terms are, do we have any like terms? Here we have an x cubed, right? There's no other x cubed, so we'll just bring down the x cubed. Now let's go in order. Now let's see the x squareds, right? So we have 3x squared. Do we see any other 3x squareds? X squares, though we don't, so we just bring it down. And also we don't have no like terms, with a negative 2x, so we just bring it down, minus 2x. And we just bring down the constant, which will be negative 6. So here, there's no terms that you can combine because all these are called unlike terms. So this is my my evaluation of the function. The f function times the g function will give us x cubed plus 3x squared minus 2x minus 6. Okay, now these are called the composite functions. So first we're going to do f composite g or f of g. And then for b part, it's going to be g composite f or it's called g of f. And for c part, it's going to be g composite g or g of g. So let's start with a. This is a definition, guys. When you have f composite g of x, this is a definition, okay? So it's going to be f of g of x, which means I'm going to plug in g of x, the x minus 9, for every x value in the f. Okay, so for example, let's bring it down here. You see, so I'm going to plug in g of x, right? So g of x is x minus 9, so we plug it in here. Now we're going to go to the f function and plug in x minus 9 for every x. Okay, so if we do that, it's going to give us x minus 9 plus 4. Okay. which would just be negative 9 plus 4 will give us x minus 5. So this is the solution for the f of g function. Now let's try the g of f. Okay, in similar manner. This is the definition, the g composite f of x. This is my definition, g of f of x. So I'm going to go and plug in f of x, right? This is my f of x, the x plus 4. So I'm going to plug it in here for the f of x. Then I'm going to go to my g function, and everywhere I see an x, I'm going to plug in x plus 4. So it's going to be here. So it's going to be x plus 4 minus 9. Here we get x minus 5. Again, this is, it doesn't really happen often, but here we got the same answer for both the f of g and the g of f. And like I said, this doesn't happen frequently. Okay, so don't assume that every time you have f of g and g of f that you're going to get the same solution after you simplify. Okay, so they just happen every once in a while. Now comes part C, the g of g. So for the g of g, okay, I'm going to plug in g of x is equal to x minus 9. So then I'm going to go to my g function, and I'm going to plug in x minus 9 for every x, which will be right here where the x minus 9 is. So it's going to give us x minus 9 minus 9. So it will give us x minus 18. So this is, evaluated g of g function here. Okay. Now, again, we're doing the same thing, but we have different functions. The f function is x squared, and the g function is x minus 1. So again, to find f of g, right? So we're going to go to my f function, right? And we're going to plug in x minus 1 for every x, because g of x equals to x minus 1. So if I go to my f function, right, the f function is x squared. So I'm going to square the x minus 1. So it's going to be x minus 1 times x minus 1. So after we do the FOIL, we're going to get x squared minus x plus 1. I always tell my students, like here, like an observation here, where you have x minus 1 squared. I tell my students that if they're going for math or for engineering, they have to know how to get it from here without doing the actual FOIL. For example, here's how you do it. You're going to multiply the first term times the first term. So x times x will give us x squared. That's where it comes right here on the bottom, x squared. Then you multiply the first term times the second term. So x times negative 1 will give us negative x. And you always multiply by 2. Why 2? Because when you do the FOIL, you see you get 1. The x times negative 1 is negative x. And negative 1 times x will give us negative x. So it's always you multiply by 2. So again, you multiply the first term times the first term will give us x squared. You multiply the first term times the second term will give us negative x. You multiply by 2. That's where we get the negative 2x from. And then we multiply the last term by itself. So negative 1 times negative 1 will give us a positive 1. Okay. So this will give us x squared minus 2x plus 1 is a simplified version of the f composite g of x. So now we're going to do the g of f. So g of f, right? So this is my definition. So it'll be g of f of x. So I'm going to plug in the f of x, right, which is x squared. I'm going to plug it in here, right? Just substitute it here. And then we're going to go to my g function, and I'm going to plug in x squared for every x. So here's my g function. So I'm going to plug in x squared for the x. So it's going to give us x squared minus 1. And that's my solution here, guys. Now let's do the g composite g. So again, I think I went one extra. So g composite g, right? Again, this is my definition, g of x. So g of x is equal to x minus 1. So I have g of x minus 1. I'm going to go to my g function and plug in x minus 1 for every x, which will be here where the x is. So it's going to give us x minus 1 will give us x minus 2. So here we have x minus 2 to evaluate the g composite function. Let's see what's next. Again, let me go back here.
Okay, I'll take over. I think we lost Mr. Isasi. So does the function have an inverse function? One of the things that earlier we did was we wanted to see if it was a function, and we used the vertical line test. But now to determine if it has an inverse, then we want to use a horizontal line test. So in order to have an inverse, it has to be a function, and then you can use the horizontal line test. So here I have a line, so I know that's a function. So it passes the first test. And now I need to see if I draw a horizontal line, then it's going to pass the horizontal line test, and it's going to therefore that means that you're going to have an inverse. Okay, and you can draw this line anywhere on the graph. So let's try an example. So determine whether the function has an inverse. So first, you look at your equation, and if I was to draw this, I know it's a line, and so the line is going to be a function, and it's also going to pass the horizontal line test. So it has an inverse. How are we going to find this inverse? Okay, so to find the inverse, these are the steps. We're gonna replace f of x with y. So anywhere you see f of x, we're gonna replace it with y. And then we're gonna interchange the x and y. Okay, so that's what it means to have an inverse, is that your domain for the first function is now the range, and the range is now the domain. And so for short, we interchange these values. And so I'm gonna go ahead and interchange them. So now I have x is equal to 5y plus 4, and then we're going to solve for y. So I'm going to subtract 4 on both sides, and then I'm going to divide by 5. So I end up with x divided by 5 minus 4 divided by 5. And to finish it off, we're going to we're going to replace that with the symbol for inverse. So the symbol for inverse is this -1 up here. So we're going to have f of -1x is equal to 1/5 x minus 4/5. So this is your inverse here. Okay, so I know your exam is, for most of you, is this week. So it might be due this Sunday, or you might be taking it early next week. So either way, you can have a copy of this PowerPoint. Right here on top, there's an arrow with a box around it. If you click on it, it's going to let you download this file. Okay, and then also, this is recorded. So let's say your test is next week, then you can always come back and view the video again if you need to, or we went too fast. Okay, so I just want to wish everybody um, success, right, for your first exam. And if you have any questions, we do have some tutors here that can help you. And thank you again for joining us. And starting next week, what's going to happen is we're going to be separating. So, for example, if you're in 1324, then you're going to come into this room. Then we'll move you to another room with Mr. Isasi. And then the 1314 students will stay here with Mr. Carizales and I. So thank you again for coming with us to Friday Happy Math Hour. And I'm going to go ahead and pass it over to our wonderful staff.
Yes, thank you, Ms. Chuka. Thank you, Mr. Sasi, for your wonderful presentation. Again, we do want to remind you all about the previously recorded sessions, which are available on the YouTube playlist. This session will also be available on that playlist later today. Also linked at the end was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to us before you log out. If you would like to download a copy of the presentations, you can go to the top right corner and click on the arrow with the box going down while the presentations are up on the screen. That'll allow you to download the PowerPoints. And before you leave, we want to share the TVE sessions that we will have next. Today at 1 p.m., we will have a presentation on registration with Debbie Santana. And join us again next week at 11 a.m. for Happy Math Hour, where Math 1314 will be covering standard form of quadratic equations and graphing, and 1324 will be covering writing exponential equations in logarithmic form. Our 1 p.m. session that day will be Memory Tricks with Carrie Van Hoot. Thank you all again for coming in today. We hope you all have a lovely weekend. And again, if you all have any questions, feel free to use the chat box or your mic. We hope to see everyone again next week for Happy Math Hour. Thank you.